Hi, in the last video we discussed about introduction of the probability and addition rule. Okay, in the addition rule there are two formula for finding the probability of A or B. You see that probability of A or event B is equals to PA plus PB, probability of A plus probability of B if A and B are disjoint. And the formula for probability of A or B is PA, probability of A plus probability of B minus probability of A and B if A and B are joint. Okay, that's what we discussed last time. Okay, so today we will be discussing about the multiplication rule and conditional probability. But before that, I want to talk about the independent events. Two events A and B are independent if occurring of A does not affect the probability of occurring B. If event A and B are independent, then the happening of A does not affect the happening of B. For example, if you pick a card from 52 cards, what is the probability of king? The probability of king in that case would be let's say PK equals to 4 over 52, right? That is the probability of king, right? But if you replace it back and if you pick the second card, then the probability of king in the second time is also 4 over 52 because the scenario did not change. There are 52 total cards, there are 4 kings, right? But in case if you do not replace that king, that card back, and if the first card is king, what is the probability that the second picked card, if you do not replace back, the second pick card, let's say K1 is the first pick king, and then second pick card is king, is equals to 3 over 51, right? Because if the first one is king, then the second one will be king, given that the first one is king. Okay, that will be 3 over 51. For this, the correct notation is probability of K2 given that K1 is the king, given that the first one is the king. Okay, that is 3 over 51. So in that case, the probability of picking the king on the first trial and the second trial, they are different, right? One is 4 over 52 and another is 3 over 51. So they are different, meaning that the probability of happening the first event is changing the probability of happening the second event. Okay, that's why they are the dependent events. If you pick a card from a pack of 52 cards, but if you do not replace back and if you pick the second card, then those picking the first card and the second card are the dependent events. Okay, they are dependent. One probability is depending on the other. But if you replace back, then the picking the first card and the second card are independent because the probability does not change on the first trial and the second trial. Okay, now when two events are independent, in case of the two events are independent, if you want to find the probability of A and B or probability of happening both, excuse me, the formula will be PA times PB. Okay, let us see an example. Suppose that 30% of breast lump biopsies results are malignant. Okay, what is the probability that two successive outcomes will be both malignant? That's what it is asking. Okay, so if you pick randomly, if you pick a biopsy, okay, the probability that biopsy is malignant is 30%. But if you pick the two lab result randomly, two biopsy result randomly, what is the probability that the first one is malignant and second one is malignant? Malignant 1 and malignant 2, because they are independent, right? Whatever you pick does not depend on the second pick, or the second pick does not depend on the first pick, right? That will be probability of M1 times probability of M2. That will be 0.30 probability of malignant on the first pick times the probability of malignant in the second pick. Okay, that will be 0.09. So if you randomly pick the two biopsy result, then the probability that both of these are malignant is just 9%, right? 0.09. That is just a 9%. Okay, so this is the case of independent events. Let us see another example. 44% of the US population had blood type O, and 15% of all population have Rh negative, which is independent of blood group. It is saying that Rh negative is in whatever blood group type you pick, 15% are Rh negative. Okay, so what is the probability of O? It is 44%, 0.44. What is the probability of Rh negative? is 0.15, right? What is the probability of having the both? That will be O and RH negative, right? That will be, you multiply those because there is and. You see that? Both means and. Both O and RH negative. That will be 0.44 times 0.15. So whatever you get will be the final answer for this. Let me use calculator for that. So when I use calculator, I got 0.44 times 0.15. I got 0.066. That is 0.066. That is 6.6% of the people have a type O and RH negative blood type. Okay, guys, that's how we do it. That was the independent event case. So the next type is the dependent events. So what types of events are dependent? Look at this. When the outcome or occurrence of the first event affects the outcome or the occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. Okay. When two events are dependent, then the probability of both occurring A and B is given by this formula: PA times probability of B given that A already happened. That's how we read. Probability of B given that slash is the given that A already happened. Okay. So let's say that where B slash A is called conditional probability of B given that A happened already. So example, a card is drawn from a deck and not replaced. Then a second card is drawn. Find the probability of getting a queen and then ace. What is the probability that if you draw a card for the first time, what is the probability that it is a queen? There are 4 queens, there are 52 total cards, right? That is the probability of queen. Now, the second one is finding, it is saying that queen and an ace. Suppose you pick the first one queen, what is the probability that the second is ace, given that the first one is queen? You see that? Probability of ace given that the first one is queen. So how you are not replacing because it says not replaced here, right? So how many cards left? 51 cards left. How many aces are left? 4 aces, right? Because the first one we are assuming that the first one is queen. Okay. So what is the probability of A and A and Q? What is the probability that you get ace and queen? That will be probability of queen times probability of ace given queen. So A and Q or Q and A are the same thing. Okay, they are the same thing. So you will have 2 versions of this formula. I'll talk about that later, but for now let us do that. Probability of queen is 4 over 52 and probability of ace given queen is 4 over 51. If you multiply these two, what do you get? Let me use calculator. 4 over 52 times 4 over 51. If I do that, I get 0.006. 0.006. That's what I got. Okay, that is 0.6% chance that when you randomly pick 2 cards, you will get a queen and an ace. Okay, that's what we say. Okay, so these are these are some examples. I'm giving some more examples on the conditional probability or the dependent events. Okay, find the probability of A and B in case of the dependent events. Let us see another example. Here, a manufacturer makes 2 models of glucometer. Model 1, which accounts for 80%. What does that mean? That means probability of model 1 is 0.80. That's what you get. And model 2, which accounts 20%. Probability of model 2 is 0.20. That is the model 2. Okay, of unit cells. Because of the defects, the manufacturer has to replace 10% of its model I. So what does that mean? That means the probability of defect in the model 1, right, is equals to what? It is 10%, 0.10. And what is the probability of defect in the model 2? Because what it says is 10% of the model 1. That means probability of defect, given that it is from model 1. Okay, it is from model 1 is 10%, and the other one is 0.18, 18% in the model 2. That's what it is saying. If a model is selected at random, find the probability that it will be defective from model 1. It says probability of defective and model 1. That's what it is asking. What is the probability that is defective and model 1? Okay, so that will be, what is the formula for that? Probability of model 1 times probability of defective from model 1, right? I mean, again, as you said, you can write model 1 and defective, right? So what is the probability that it will be defective and model 1? It should be and, okay? You can write this as and model 1. So probability of defective and model 1, or model 1 and defective, they are the same thing. So what I'm doing is I'm doing probability of model 1 times probability of defective given it is model 1. So probability of model 1 is 0.80 times probability of defective from model 1 is 0.10, right? So you get 0.08. That is the 8% chance that if you pick an item randomly, what is the probability that it will be model 1 and defective? That will be 8% chance. Similarly, defective and model 2, probability of defective and model 2, that will be probability of model 2 times probability of defective given from model 2. That will be 0.20, right? Times probability of defective from model 2 is 0.18. You see that? That will be 0.36. That will be 3.6% chance that the item you picked, randomly picked, will be model 2 and defective. Okay, guys? So these are the examples for the multiplication rule. You multiply two probabilities if the events are dependent and independent. That's all about the multiplication rule. So the next thing what we want to do is we want to do the conditional probability. What we just discussed is we discussed that probability of A and B. What is the formula for that? It is probability of A times probability of B given A, right? That is the formula we just discussed, right? Now, I have to solve for probability of B given A. That means I have to solve for this conditional probability. This is called the conditional probability. I want to solve for that. So I need to divide by PA on both sides, right? You see that? So what do you get? Probability of B given A is equals to, that will cancel out. So you get P, A and B, okay, over P, A. That's what you get. Now, this is another formula. This is called the conditional probability formula, okay? So what does it find is probability of B, event B, given that A happened already, is same as probability of A and B divided by probability of A. Look at that. This probability of A, this will be known to you because it happened already. So it will be known to you, and on the denominator you will get that probability of A. You do probability of B and A or A and B, whatever you write, because on the end you can write A and B or B and A, not a problem. So the probability of B given A happened already is equals to probability of A and B divided by that thing after the slash will go in the denominator, probability of A. Okay, guys? So this is the formula. So what I'm going to do now is I want to give this example in your slide, okay? I'm going to do that example. For that, since it has many parts, I want to erase what I have here because the formula is already given in the slide, okay? All right, let's discuss this. In a study of 555 subjects, total subjects are 555, 50 used drugs. But their drug tests show only 45 used drugs. And 5 of them are false negative, although they use the drugs, but the test shows negative. You see that? Total number of people who use the drugs is 50, but only from the test, only 45 shows that they use drug. That means 5 of them, although they use the drug, the test is showing negative. That is called false negative. Out of the remaining 505 non-drug users, okay, out of the remaining 505 non-drug users, 25 have positive test result. You see that positive test result means? So out of remaining 505 non-drug users, the test result, although they are non-drug users, it is the false positive, right? 25 of them have positive test results. Make a table for this with 2 columns, T plus and T minus. You need to make 2 columns, T plus and then T minus, okay? You want to make those 2 columns. And then 2 rows, D plus and D minus. Let me do D plus is the positive test, the drug users, and D minus is the non-drug non-users, okay? This is what we got, okay? And let me write down the total here. I will write the total here as well. Let us first write down what are the given things. The total subjects is 555, but 50 uses drug. That means D plus means drug users. 50 of them. The total number of people who use the drug is 50. And how many left out of 555? How many are non-drug users? That is 505. 505 are the non-drug users. These are the given things. Also, out of the remaining 5, okay, by the way, but their drug test show that 45 uses drug. The test positive. Drug users test positive is 45. Okay, that is 5 of them have false negative results. Out of the remaining 505 non-drug users, 25 have positive test results. So 25 of them have the positive test, because these are the positive test results. These are the negative test results. These are the drug users. These are the non-drug users. Okay, now, so what is left? The total is 50. 45 have positive test result. So 5 of them will have negative test result, right? I'm using the red color for the one that is not given. Okay. Similarly, out of the 505, 25 have positive test result. They are not the drug users. They are non-drug users. Okay. Drug non-users, I would say. 505, but 25 uses the 25 has the test positive. So 480 will have negative test result. You see that? Now, how many of them have the positive test result? 45 plus 25. The total positive test result is 70. And how many of them have a negative test result is 485. What is the total of the total? You can add this total column or add the total row. That will be 555. So we did the constructed the table. Okay. So make a table for that too. We did that. Now number one is, if a subject is selected randomly, find the probability that, number one, find the probability that the subject uses drug, that means D plus, given that he has a negative test result, T minus. Probability of drug users from the negative test result people. That's what it is saying, right? Given that they are, if you pick a person randomly, what is the probability that that person has a positive, that person is drug users, given that he has negative test result. So what is the formula again? Let us look at that. You do D plus and T minus, D plus and T minus, right, over that thing after the slash, go to the denominator, probability of T minus. Now, what is D plus and T minus? How many people have D plus and T minus? 45, right? What is the probability though? Probability is 45 over 555 divided by probability of T minus. How many are T minus total? 485, right? The total T minus is 485. 485 divided by 555. You see that? Now what do? That 555 in the denominator and denominator of the both fractions. So what is the answer? 45 over 485. That is the first one. How about the second one? It says, find the probability that the person has a positive test result. Test result is positive test result, okay? So a probability of T plus, given that he never uses drugs, although he is not drug users. That's what you want to find out. If you select one person randomly, what is the probability that the person has a positive test result, given that he never used the drug? He is in this group, but you want to find out the probability that he has a positive test result, okay? That will be probability of T plus and a D minus divided by probability of D minus. You see that? So what is the probability of T plus and D minus? T plus and D minus is 25, right? 25 over 555, because you need to divide by the total, because it is the probability, right? And divide by D minus is 505. The total D minus is 505. So 505 over 555. So they are in the denominator. So that will be the final answer here is 25 over 505. See that? Let's do triple I. So triple I is, find the probability that the subject has a positive test result, probability of T plus, given that he uses drug, D plus. What is the probability that a person will have a positive test result, given that that person is a drug user? Again, do the same formula, P probability of T plus and D plus divided by the thing after the slash goes in the denominator with probability D plus. Okay, so what do you get? You get T plus and D plus. T plus and D plus is 45 over 555 divided by D plus. Probability of D plus is 50, right? 50 over 555. If you do that, you will get 45 over 50. You see that? So this is 90%, right? 0.90. So if you are a drug user, then the probability that the test result is positive is 90%. But you see that if you are not drug user, the probability that the result is positive, that means the false positive test result is 25 over 5 over 5. It is small. It is almost unlikely. So this is also small. This is also unlikely, but this is likely, right? How about the IV? Find the probability that the subject uses drug, probability of D plus, right? D plus, given that he has a positive test result. He has a positive test result. If a person has a positive test result, what is the probability that he uses drug? That's what it is asking, right? So probability of D plus and T plus given by probability of T plus. That will be D plus and T plus is 45 over 100. Sorry, not 100, 555, right? Divide by, what is the probability of T plus? 70 over 555. So the answer is 45 over 70. So this is also likely, but those are very small probability. I and double I are small probability. Triple I and IV are not very small because it is more than 50%, right? So this is 90%. This is, what is 45 over 70? If I use calculator, you get 45 divided by 70 is 0.64. That is 64% chance, right? 0.64. 64% chance that if you use if your test result is positive, then the probability that you use drug is 64% chance. Okay, guys. So this is how we find out the conditional probability. This is also very, very useful. Okay, guys. All right. Thank you.